The next submission is an oral presentation by the Ontario Clean Air Alliance, as outlined in CMD 13M51.36. I understand that Ms. Angela Bischoff will make the presentation. Please proceed.
Thank you, panel members and members of the public. I'd like to recognize that I'm on traditional Iroquois territory. I represent the Ontario Clean Air Alliance, an NGO committed to moving Ontario onto a renewable energy future. I'm also a resident of Toronto, living just a short bike ride from the GE Hitachi plant. I'll be focusing my presentation today on the emissions coming from this plant endangering the neighborhood. The GE Hitachi plant, which manufactures uranium pellets for more than 50% of Canada's nuclear power generation, sits in the middle of a dense residential neighborhood. The plant receives 1,800 tons of uranium powder each year. This form of uranium is radiologically hazardous and can affect the surrounding neighborhood through the release of airborne emissions during transportation, through accidents or spills, and through the emissions of the plant's internal processes. Would this plant get a license to build in this location if it applied for one today? I doubt it. It began processing uranium in '55 in a large industrial zone, which has since been turned into a bustling residential community. Given what we know today about the health dangers of uranium, it's beyond understanding how this plant has continued to operate in the midst of a densely populated neighborhood. Are there siting regulations that prohibit nuclear facilities from being built in the middle of a dense residential neighborhood? Was this plant grandfathered when siting regulations came to be? And if there are no siting regulations for Class 1B facilities such as this, why aren't there? I request answers to these questions. The CNSC acknowledges many samples of the soil surrounding the GE Hitachi plant are contaminated. The highest level of contamination recorded was 21.2 parts per million, which is considerably close to the 23 parts per million residential soil limit, and highly elevated in comparison to the background level of uranium in soil at 2.5 parts per million. Then again, industrial limits are 300 parts per million. So why is the guideline for industrial sites so much higher? And if soil on the site was found to be 295 parts per million, let's say, would that be acceptable? Because this really isn't an industrial zone. It's a residential neighborhood. Into this community, in the last 5 years alone, the GE plant released 25.9 grams of uranium emissions. And here's why this should be of concern to us, I think. Uranium dust released from the plant into the surrounding atmosphere does not recognize the fence line. It is easily inhalable and readily transported to vulnerable tissues of the body, including the brain and lungs, but can also cause damage to internal organs, notably the kidneys. It may also affect reproduction and the development of the fetus, and increase the risk of leukemia and soft tissue cancers. It contaminates the soil in which people grow food and children play. Uranium dust has a long half-life, which assures its presence in air, land, and soil for a very long time. This uranium dust deposited onto soil and surface water can leach into groundwater. It can migrate long distances and can be deposited onto vegetation and absorbed through foliage or taken up by plants' root systems. Because uranium bioaccumulates in plants and animals, it can gain entry into the human food chain. The Lansdowne and DuPont plant also releases uranium discharge into our sewage systems. Since 2007, the Hitachi plant has released almost 8 kilograms, and in 2009 alone, it released 2.2 kilograms of uranium into our local sewage system. 2.3 kilograms of uranium is capable of contaminating 100 million liters of water to over the drinking water standard. Does this uranium make its way into our drinking water, or is it filtered out? If so, how? If not, it can be absorbed by our bloodstream and taken into the kidney, which can then cause serious damage due to its heavy metal characteristics. The sad fact that the license limit is 9,000 kilograms per year shows just out of touch the CNSC regulations are. How can the CNSC possibly defend such a limit? And is this indicative of other CNSC regulations? Is this how the CNSC fulfills its mission of protecting the health of workers, the public, and the environment? This proves to me that just because emissions of radionuclides from a facility lie within or below current limits does not mean they do no harm. I'd like to know why Toronto Public Health is not monitoring water releases into the sewage system. The key findings of the CNSC soil sample report that, quote, uranium levels pose no health risk, unquote, cannot be substantiated. For this we know. No level of radiation is safe. For years, the nuclear industry and government agencies claimed that only acute exposure to radiation was harmful. However, new research confirms that chronic, low-level radiation can cause a multitude of health problems. The Beer 7 Committee study confirms there is a linear, no-threshold risk model associated with radiation exposure. That is, the smallest dose of low-level ionizing radiation has the potential to cause a small increase in health risk to humans. Human-made radiation at low chronic levels is associated with increased risk of cancers, genetic damage, birth defects, and mental retardation due to in utero exposure. As the overall lifetime exposure increases, so does the risk. Also, you only need a single mutation in a single cell in a single gene to cause serious health effects. Releasing uranium into the air and water anywhere, let alone within a densely populated city, is a health hazard. There is no safe level of exposure to ionizing radiation. Internal exposure can be far worse than external, as it is localized and therefore more likely to impact the DNA directly, causing mutations. Ionizing radiation causes harmful effects because it is genotoxic. It damages DNA at the cellular level. Low doses can have significant long-term genetic consequences, causing genetic instability, resulting in an increased risk of cancer, lymphoma, and leukemia for the individual exposed, and heritable damage as well. The good news is that there are viable, low-cost alternatives to meeting all our electricity needs without the use of nuclear reactors. Water power from Quebec, conservation, and made in Ontario green energy all have a lower carbon footprint, lower financial costs, no long-lived radioactive waste, no proliferation risks, are safer, and create more jobs. It's only a matter of time before this plant is shut down, along with the entire nuclear fuel chain, and replaced with renewable, clean, safe, and lower-cost electricity that doesn't endanger life or create long-lived radioactive waste that needs to be isolated from the environment for 1 million years. So, to conclude, we're asking for the phase-out of all nuclear power stations when they come to the end of their lives. For Pickering, that means 2014, and for Darlington, that means 2020. And until that time, we're asking for independent third-party monitoring and stricter emissions limits of this plant. Uranium, air, and water emissions must be ratcheted down year by year, below existing releases, the goal being to reduce the emission limits to zero, because no emissions are safe. Detailed decommissioning plants must then be developed with full community involvement. Thank you.
Thank you. Question? Dr. McDill?
Thank you. Were you here this morning when Nordian was presenting?
No.
Okay. So I'll just repeat a question then that I asked this morning. Could I ask staff to repeat the analysis of emissions to sewage treatment? How it's decided that it's appropriate? You could repeat Nordian as well, just because it's a good comparative.
Sorry, Patsy Thompson for the record. So this morning we talked about the sewer use bylaws that are in place in most municipalities. Normally those sewer bylaws specify that radionuclides from CNSC licensed facilities can be released to the sewer under certain conditions set by the CNSC. And so the calculations are done on the basis of a derived release limit based on 1 millisievert per year, taking into consideration the amount of water in the sewer systems, and looking at exposures, for example, to sewer plant workers, and eventual discharge to Lake Ontario in this case, for example, and concentrations that would be expected at the point of discharge. There's also an expectation from the licensees to put in place control programs to minimize those releases, and that's what essentially the performance from GE shows, that the actual discharges to the sewers are much lower than their release limit. But it's essentially done through sewer use bylaws and calculations based on the public dose limit.
I think I asked this morning if it was possible to convert a gigabecquerel to a gram. Is that something we can try and do maybe tonight or tomorrow?
Patsy Thompson for the record. We can come back tomorrow with the information.
Dr. McDill, anything else? Anybody else? Okay, thank you. You have any final word?
I feel like I had, half a dozen questions in my presentation, none of which were addressed. That one partly was addressed, that it falls within municipal bylaw guidelines. But what about all the other questions? Will they ever be answered? Should I follow up with an email or?
Most of your questions have been dealt with and will continue to be dealt with tomorrow. So thank you for the intervention.
So I don't get to hear the answers?
You can listen, it's webcast, and then you can read the proceedings when they're published. Thank you.
Thank you.
I'd like to move on